Hello everyone, welcome to another great day of being a tiger. Today we are going to work on the Pythagorean theorem, and we'll talk about its converse and some inequalities as well. Today we only have one vocabulary word as a Pythagorean triple, and that's going to be three whole numbers, meaning no decimals or anything like that, that will work in the Pythagorean theorem, which is of course a squared plus b squared equals c squared. So three numbers that when you plug them in and you square the two smaller ones, they add up to the biggest one squared. The easiest example would be 3, 4, and 5, which works out. But we'll look at some more examples of those in just a little bit. So here we go. We have the Pythagorean theorem. Make sure you know it only works for a right triangle. It only works for a right triangle. And the other important thing is that C, the side that goes all by itself on one side of the equation, has to be the hypotenuse. The hypotenuse is the longest side. It is the side that is opposite of the right angle. It is the only side that doesn't touch the right angle. So C, the one that's by itself, is the longest side, the hypotenuse, the one that doesn't touch it, opposite the right angle, all of those things. You have to be careful of that. If you switch it up, that's going to get you the wrong answer. All right, so here we go. First example, find x. Right here, first thing we have to do is figure out, is x the hypotenuse or one of the legs? Well, 4 and 7 are the ones that touch it, so those are the legs. So I do a squared plus b squared equals c squared. 4 and 7, doesn't matter which one's a or b. 4 squared plus 7 squared equals x squared. 4 squared is 16. 7 squared is 49. Add them together and we get 65 is equal to x squared. Now to solve this equation, we take the square root of both sides and we have x equals the square root of 65. 65 is not a perfect square. 64 is, but 65 is not. 65 also doesn't have any perfect square factors, so that's as far as we can go if we want an exact answer. Remember our perfect squares, we have 2 squared is 4, 3, 4, 5, 6, 7, 8, 9, 10, and it keeps going on. So those are all of our perfect square, or that's the start of our list of perfect squares. And since 65 can't be divided by any of these, we just leave our answer there. Some of the problems, you'll want to just round them off to a decimal place. So we do the square root of 65, and it gives us about 8.1 if we wanted to round it off. Just type it in your calculator and see what you get. All right, here's another example. For this one, we again have to figure out which side is our C, the hypotenuse. Here's our right angle, so opposite of it, 12, is our hypotenuse. So our a squared plus b squared equals c squared. X and 8 have to be a and b. So x squared plus 8 squared equals 12 squared. X squared plus 64 equals 144. Subtract 64 from both sides, and we have x squared equals 80. Take the square root, so we have x equals the square root of 80. Now 80 was not one of those numbers in our list of perfect squares, but it is divisible by one of those numbers in our list of perfect squares. If we do 80 divided by 16, 80 divided by 16 we get 5. So we break 80 apart to the square root of 16, square root of 5. 16 is a perfect square, and the square root of 16 is 4. So 4 radical 5 is our answer in radical form. And we reviewed simplifying radicals at the beginning of this semester because we knew this Pythagorean theorem in right triangles was coming up. So you always want to divide the number under the square root into perfect square factors. We could divide 80 into a bunch of different ways, but 16 and 5 is the one we want because 16 is a perfect square. The square root of 16 is 4. The 5 is not a perfect square, so it's stuck under the radical. All right. Another example asking us to find x. X again is our hypotenuse on this one. So we get a squared plus b squared equals c squared. 5 and 8 can be a and b. You can switch those, but x has to be over here. 25 plus 64 equals x squared. Add those up, and we have 89 equals x squared. Take the square root. Radical 89 is equal to x. 89 is not a perfect square. 81 is, which is lower than it. 100 is, that's bigger than it, so it's not a perfect square, and it doesn't have any perfect square factors. So C is our answer. One thing to add in here, if you remember from algebra class, when you take a square root to solve an equation, you should have both the positive and negative answer. But for geometry and a lot of our practical applications here in a triangle, you can't have a triangle with a negative side length, so we only care about the positive answer. So we're just going to write that. And again, you'll be doing some problems that ask you to round these off to the hundredth. So if we do the square root of 89, we get about 9.4. To round off, just type in your calculator, see what you get. Again, this time the x is not the hypotenuse, 12 is, so 6 squared plus x squared equals 12 squared. 36 plus x squared equals 144. Subtract 36 from both sides. We have x squared equals 108. Square root both sides. X equals, and now we need to find perfect square factors of 108. Perfect squares are 4. Seems like 4 might work, but let's see if there's anything bigger. 9, maybe. 9 will work. Anything bigger than that? 36. Let's try 36. If we do 108 divided by 36, you get 3. So I'm going to break this apart to radical 36, radical 3. The square root of 36 is 6. 3 is stuck under the square root. So we have 6 radical 3. B is our answer. As you heard me say, there are other perfect square factors, like 9 was one of them. If you divide 108 by 9, you get 9 and 12. So that would give you 3 radical 12. Well, this and this aren't the same thing. The problem is 12 isn't simplified all the way. That also has a perfect square factor. 12 is 4 times 3. The square root of 4 is 2. 3 times 2 is 6, and the radical 3 is stuck. So if you don't find the biggest perfect square factor right away, that's okay. You'll just have to continue going to finish it off. All right, Pythagorean triples right here. This is really just a vocabulary word more than anything else. Here's some examples: 3, 4, 5, 5, 12, 13, 8, 15, 17, 7, 24, 25. Again, the reason why all of these are called Pythagorean triples is because none of them are decimals. None of them have those weird square roots. They're nice, even, whole numbers, but they work in the Pythagorean theorem. Like, let's just take this one as an example. 5 squared plus 12 squared equals 13 squared. 5 squared is 25. 25 plus 12 squared is 144, and 13 squared is 169. When you do 25 plus 144, you get 169 on both sides, so that Pythagorean theorem works. So here's just some common examples. Those are all Pythagorean triples, more Pythagorean triples, more Pythagorean triples, more Pythagorean triples. That's all there is to it. They have to be numbers that work in the Pythagorean theorem that are just whole numbers, no decimals involved. It says to use a Pythagorean triple to find x. I wouldn't do that. I would just plug it into my Pythagorean theorem and see what I get. I would know, since it's wanting a Pythagorean triple, that x should be a whole number, not a decimal, nothing weird like that. So this is my hypotenuse, that's C. So 24 squared plus x squared equals 26 squared. 24 squared is 576. 26 squared is 676. When you subtract that from both sides, you end up with x squared equals 100. And you square root both sides. Square root of 100 is 10. which again, we expected it to not be a decimal or no weird radical because it said it was a Pythagorean triple. All right, here we go, solving some real examples. It says a 20-foot ladder, so that's our hypotenuse, is placed against a building to reach a window that is 16 feet. So this height here is 16 feet from the ground. How far is this distance here? Again, leg, hypotenuse. So x squared plus 16 squared equals 20 squared. 16 squared is 256. 20 squared is 400. 400 minus 256. You have x squared equals 144. Square root both sides. Square root of 144 is 12. Here's another example. There's just no picture. 10-foot ladder, so that's our hypotenuse. That's the length of the ladder. Is placed up against the building. Here's our building. The base of the ladder is put 6 feet away from it, so that's 6. How high does it reach up the building? X. So 10 is our hypotenuse, so we have 6 squared plus x squared equals 10 squared. 36 plus x squared equals 100. Subtract 36. X squared equals 64. Square root. Square root of 64 is 8. And on we move. All right, the converse of a Pythagorean theorem just says if you put in the 3 side lengths, a squared plus b squared equals c squared, and it works. If these two added together equals c squared, a squared plus b squared, if that equals c squared, then it has to be a right triangle. So if you plug in 3 side lengths of a triangle and it works, then you know it was a right triangle. Really, this leads us to, well, what if it doesn't work? What if we do the 2 short sides squared, add them up, and we see does it equal the last side? What if it doesn't? What if a squared plus b squared is bigger? Or what if a squared plus b squared is smaller? What does that mean about the triangle? And well, here it is. Those are our Pythagorean inequalities. And what this tells us is that if a squared plus b squared is bigger than c squared, the 2 shorter legs, square them, add them up. If that's bigger than the third side, then it is an acute triangle. If you do a squared plus b squared and it is smaller than the longest side squared, if a squared plus b squared is less than c squared, so again, the Pythagorean theorem didn't work out, they don't add up to being equal, that means that it is obtuse. They usually write it as comparing c squared to the 2 sides added up. They do it c squared compared to a squared plus b squared, because then the inequality, when you say less than, it's acute. And we're used to thinking of acute angles as being small or less than 90. And they write it as c squared compared to the a squared plus b squared, because again, if c squared is bigger than it, that's going to be calling it obtuse, and we're used to obtuse angles being bigger than a number. But you can write it, think of it this way or this way. It doesn't matter which one you think of. You just need to know that if this inequality is true, it's acute. If this inequality is true, it's obtuse. I personally have it memorized the way it says up here. C squared is less than a squared plus b squared. That makes it acute. And if c squared is greater than the other 2 sides added up, that makes it obtuse. So let's take a look at how this works. First it says, determine whether those numbers can be a triangle. To do that, we have to take our 2 smallest ones and see if it is greater than the third side length. 9 plus 12 is 21. That's greater than 15. So yes, these can be a triangle. That's the first part. If so, tell if it's acute, right, or obtuse. All right? So 2 short sides, 9 squared plus 12 squared. We want to compare that to the longest side squared. 15 squared is 225. We are going to compare that to 9 squared, 81, plus 12 squared, 144. If we do 81 plus 144, we have 225 compared to 225. Since they're equal, that makes it a right triangle. Yes, because the 2 short sides add up to more than the last, and right triangle because a squared plus b squared did equal c squared. Here's another one, same directions. So we take our 2 short sides, 10 plus 11, and see if it's bigger than 13. again, 21 is bigger than 13, so yes, this is a triangle because the two short add up to longer than that. Now to find out what kind, acute, right, or obtuse, we do our longest side squared, and we're going to compare that to the two short sides squared added up. 13 squared is 169. Compare that to 100 plus 121. 169 compared to 221. C squared is less than, since C squared is less than those two added up, that means it has to be acute. Right here, 7, 8, and 14. 7 plus 8 is 15. 15 is greater than 14, so it's yes. So that's gone right now. And then we compare 14 squared. We compare that to 7 squared plus 8 squared. 14 squared is 196. We compare that to 49 plus 64. 49 plus 64, 196 compared to 113. Since c squared was bigger, when c squared is bigger than a squared plus b squared, that makes it obtuse. And then our last example here, for our last example, we are going to do 14 plus 18 to see if it can be a triangle. 14 plus 18 is 32. That has to be bigger than 33. And since 32 is not bigger than 33, we say no, it is not a triangle. And with that, we are done. See the email or Canvas for your homework. Bye.